All right, so let's introduce another couple of data types. And so a couple of videos ago, we went over something called a character. And I said that a character could be any lowercase letter, any uppercase letter, any number, any sort of special punctuation or symbol like that. Escape sequences, like new lines, for instance, are considered to be characters. And even the spaces between these things are considered characters. Well, that being said, if you have a character data type, well, then it might not surprise you that you can create a character variable, just like we did with integers. You just basically type out the keyword int, and then you name your integer something, and then you assign it a value, and then you start just using your variable in your program. Well, character data type follows the same sort of syntax, except for the int keyword here at the beginning. You type out what looks like the word char. And funny enough, you'll hear it pronounced both ways because it looks like the word char. You'll hear people say char. Also, you'll hear people just say care, well, because obviously it's short for character. I tend to be in the care camp. So when you hear me say care, I'm not saying care. I'm saying, well, the data type care. So after you type out the type of data, the care keyword, you name your variable something as always. And so maybe we call this first initial, and then we'll assign a value to this first initial, just like we did with our integer. But instead of just assigning like a regular old letter or number or something like that, you have to put your character between single quotes. So you can put a single character between these single quotes. Now my name is Jeremy, so my first initial is J, so we'll store a J in there. And easy as that, we've created our first character variable, and we can start using it in our program. So say we start putting off first initial, and then drop down a line and run this, and then we see that J appears out to the screen here under our integer variable 90. So easy as that. Now, the next data type that I want to introduce to you is closely related. It's a string, and a string is just, well, a sequence of anything that can be a character, put it all together, and it's a string. So all of this nonsense here that I just typed out could be considered a string. Now, this data type you need a library for. I think it's the only data type that you do need a library for, if I'm not mistaken, unless there's something I'm not thinking about. But you need the string library to be included up top. So easy name to remember, just string. This thing has all sorts of fanciness inside of it that we'll unwrap in a later video, but really cool things inside this string library. Anyways, we're just introducing the variables now, and so let's just scratch the surface and show you how you can use a string and a variable in your code. And so same old syntax here. You put the data type, and so string is our data type here, and then you name your string something. So we'll name ours greeting, and then we'll say that greeting is going to equal. Now, instead of the single quotes like you do for a character, a string goes in double quotes. Well, just like every time we've ever worked with strings so far, because, well, we've been working with strings since day one. From hello world, we've been working with strings. Notice the double quotes there. And so here we go. Our string greeting is going to be assigned the value sup, and let's just print out our string so that we can see that it works here. So drop down a line, and when we run this, there's our sup. So kind of a couple other things that I want to point out here. These are stored in memory different than these are. Characters and strings are, a little different behind the scenes. Well, as you can imagine, because they're different in front of the scenes too. But there's some pretty significant differences in memory usage and how they're stored and all that. So let's go over a couple of these things that we're not going to get too deep into now, but I want you to be aware of them because these concepts will be easier to grasp later when they get a little bit more complex. So, for instance, the sizes of them are way different. So let's use the size of trick that we just learned. Let's see out the size of a char to the string screen because, well, you can do the same thing with these. We did it with all sorts of different types of integers, but you can do the size of, well, I mean, whatever. There's the size of a character, so, and it'll work. And so let's do the size of a string to see how much memory that these use as well. And this will become pretty apparent that there's some different mechanisms going on behind the scenes here, because a character only takes a single byte. Even the smallest integer that we could store used 2 bytes, and a string, well, that takes 32 bytes. And even the largest integer that we could create took 8 bytes. So this is like storing 4 of the largest integers that you can think of. You know, that's pretty nuts. So there's 32 times the storage space taken up by a string than a character. So with memory issues, there's clever tricks that you can do with characters. If you especially only have a few characters to store, it's preferable to kind of store a series of characters, especially if there's not that many, even to one string. You know, if you have memory constraints and so forth. And there's also one other thing that I sort of want to point out in how these things are stored, and that is, at the end of every string that you'll ever make, C++ adds an additional character to it. Now, you don't really need to know that for now, but later on we're going to be creating little, I don't know, data devices. And inside of these data devices, you need to be aware that C++ adds some additional data to the end of a string. And basically what goes on here is that, say our greeting, sup, C++ stored the string sup, just as is, but then at the end it adds what's called a null character. Now, a null character has the same syntax as any escape sequence, just a backslash and then a 0 for its special character. You know, but it functions the same sort of as a new line character or a tab or whatever. You have that heads up backslash, and then the special character after the null character, what its little special instruction is, it's just a place marker at the end of the string. It lets C++ know as a sort of flag, hey, the string is over with. And you need this end of string flag for some of the advanced operations that are included in the string library, essentially. And this happens for every single string that you make. So, for instance, you can create a character, A, right? And you can make this string a single character, but the difference in memory here, besides the size of it, because they're both, you know, hugely different, is that this string A also gets a null character placed at the end. Now, you don't see that null character. When you print it off to the screen, it's not apparent. All you see is, well, sup, you know? But it's there, and you need to be aware of it later on, especially when you're creating your own sort of, like I said, data devices or storage devices that hold strings. Well, you need to know that there's an extra character in that string that you weren't counting on, and you need to allot some extra storage space for that extra character, especially when we get into something, I don't know, called arrays later. You'll understand. All right. So that's it. I just wanted to point out chars and strings and how to create variables out of them, and a couple of little behind the scenes nuances, and hopefully we did all that. All right. See you in the next one.